Today we're going to be talking about doing some measurements and how to convert between types of measurements. For example, a lot of times in the United States we use feet or inches to measure things, right? Or we use pounds and ounces. Well, we don't use the English system for science. And so we talked about during the last lab that we wanted to make sure that our scales were set to ounces, or not to grams instead of ounces. But sometimes we have measurements in one system and we want to convert to the other. Or we know what it is and how many seconds it is, but we want to find out how many hours it is. That kind of thing is the conversion that I'm talking about. So that's what we're going to talk about today, and we're going to do some practice problems. Measurement systems and unit conversions, that's what we're talking about today. So you see all the different measuring things, different types of measurements. So you can measure volume, you can measure weight or mass, you can measure time, lots of different things. So this is what I was talking about, two different systems of measurement. The English system is the one that if you live in the United States, you are probably more familiar with. So when we're making a recipe, we measure things with cups and teaspoons and tablespoons. And if you are trying to figure out how far it is from here to, I don't know, the mall, you're gonna measure the distance in miles, right? So that's the English system. And we use those here, and some other countries use it as well for certain situations, like for cooking or for sports, like football, for example. It's measured in so many yards they have to go, right, before they get the next down. That's the English system. The other system is the metric system, and that's the system that most other countries use, and it's what we use in science. And ones that are in the metric system are centimeters and meters and liters and grams or kilograms. So those are the two types of systems that we have for measuring things. Common units of measurement or things that we might want to find out how much it is, would be mass. So that's how much something weighs, except when we take weights of things and we do it in pounds, that actually measures how much gravity is pulling on something, whereas mass is supposed to be just how much of something there is. So that if you weighed the same cake, if you had a cake and you measured the mass of the cake on Earth, where there's a certain amount of gravity, and you measured the mass of the cake on the moon, where there's less gravity, the amount of mass would be the same. But if we measured how many pounds it weighs, they would weigh differently because gravity is pulling on that, so it weighs more as far as pounds go. So we use grams because that doesn't involve gravity. So that's the one that we use for science, is grams versus pounds. Your scale is going to have some gravity going on, right? What you put on the scale, even though we measure it in grams, gravity still does have an effect. We just choose to use grams. Well, one, it's the metric system, and two, it's not affected. It's not supposed to take gravity into account, right? The next thing we might want to measure is the distance. So if we need to know how far it is, like I said, from here to the mall, or we need to know how far it is from this part of the atom to the other, which this is way too big, but let's say we measured that distance, right? So in the metric system, we use the meter is what we call the base unit. So we add either prefixes to make it bigger. So kilometer is bigger than a meter, or we use prefixes to make it smaller, like millimeter is much smaller than a meter. But that's the base unit. The same thing with the gram, that's the base unit of mass. The English measurement, that's our kind of base unit for English measurement, is the foot, but then you can go down to inches, or you can go up to miles or yards or whatever. We also might want to measure the volume of something. So how much of a liquid or a gas there is. The base measure for volume is the liter. And then for the English measurement, it's a gallon. Again, you can go smaller than that or bigger than that, but that's the base unit. And then for time, it's the same in both the English and the metric. The base unit of time is the second. So I mentioned prefixes. These are prefixes that we use in the metric system. These are the three most common ones. There are other ones, but these are the three most common ones that show up over and over again in lots of different situations. So you're probably going to want to write this down. Milli means 1/1000th. Centi means 1/100th. And kilo means 1000. So if we say a centimeter, that's 1/100th of a meter. If we say a kilometer, that means 1,000 meters. So those are the three prefixes that we use very often, and you're going to see it over and over as we do different calculations throughout science and anything else that you do. So as we look at converting, like I said, sometimes you have your measurement in grams, but you really wanted it in kilograms, or you have inches, but I really need to know how many miles or whatever. To go from one to the other, there has to be a way to convert it. And that's what we're going to be talking about. In order to do that, you use unit conversions. Unit conversions let you change between different units within the same measurement system. So you could go from inches to feet, but they also let you go between different measurement systems. So changing from inches to millimeters instead. So we're going to work on doing both of those a little bit today. In order to be able to do conversions, we have to create something called a conversion factor. Again, you might want to write this down. If it's its own slide, it's probably a good indicator that it's something important. So conversion factors. Conversion factors are tools from changing between units. So to create a conversion factor, you write a fraction with both of the units that you're trying to change between, and it has to equal 1. For example, 1 foot and 12 inches are the same thing, right? So you would write a conversion factor by putting 1 foot on the top and 12 inches on the bottom. You've learned in math that anything divided by itself equals 1, right? So 3 divided by 3 equals 1. It's the same thing here. Because they're exactly the same measurement, 1 foot divided by 12 inches equals 1. So we can multiply anything by something that equals 1 and you get itself. You don't change how much of it there is. So that's why we can use conversion factors. One special conversion factor that you're going to need to know a lot throughout our chemistry class is that 1 cubic centimeter equals 1 milliliter. So if you've ever heard like on a medical show or something like that, I need 3 cc's of blah, blah, blah. cc stands for cubic centimeters, but they're usually talking, or they are talking about some medicine or an injection or something like that. And they do measure it in cubic centimeters, but what's marked on the syringe or whatever is going to be milliliters, because that's how you measure a liquid. But a cubic centimeter is the same as a milliliter. So if they say I need 3 cc's, that means I need 3 cubic centimeters, which also means I need 3 milliliters. So that's one that you need to write down because you're going to need to remember that. We'll use that over and over. We're going to take a minute and practice writing some conversion factors. So the first one, I want you to tell me, I think I may have already given this away, so I'll just tell you this one, and then you can tell me the next one. If I want to change between feet and inches, 1 foot equals 12 inches, right? We know that those are the same thing. So if I want to write a conversion factor between those two things, I would write a fraction with one of them on the top and one of them on the bottom. So there are actually 2 different conversion factors I can write from this information. First, I could say 1 foot over 12 inches, or I can flip it and say 12 inches over 1 foot. Because like we said, if we were to divide those, because they're exactly the same, our answer would be 1. In algebra, you will have learned that if you multiply 6 times 3 over 3, so you put the 6 over a 1 to make it 6, and you multiply by 3 times 3, you're going to end up with 18 divided by 6, 18 divided by 3, because you multiply across, right? 6 times 3 is 18, and 1 times 3 is 3, and then you divide. 18 divided by 3 is 6, so you just end up with the same thing. So that's why we can do this. why those conversion factors work is because we're just dividing, or we're multiplying by something that equals 1. So I want you to tell me, if I wanted to go from 1 liter to 1,000 milliliters, how would I write that conversion factor? So I'll write it down for you. 1 liter equals 1,000 milliliters. How would I write a conversion factor for that? There are actually 2 of them.
You could put the 1 liter on the top and then put 1,000 milliliters on the bottom.
Yes, and then what's the other one?
You could switch it up and put the 1,000 milliliters on the top and the 1 liter on the bottom.
Right. And I'm going to start abbreviating. So most of the time when you're doing these conversion factors, you're writing a whole lot. So we're going to do, I'm going to abbreviate a little bit. So the abbreviation for milliliters is ml, and the abbreviation for liters is L, but since my L's and ones look a lot alike, when I just do liters, I do a cursive L. So 1,000 milliliters over 1 liter. Okay, can you do 1 mile to feet for me? Do you know what the conversion is, or do you want me to write it down?
No, because I'm Canadian.
Okay. So 1 mile equals 5,280 feet. So what would those conversion factors look like?
You can put the 1 mile above the 5,280 feet, or you can put the 5,280 feet above the 1 mile.
Right. So I want you to notice something here. So I didn't put periods here. After abbreviations for metric system, you don't use periods. After abbreviations for English system measurements, you do. It's another quirky thing about the difference between those two. So just something to remember. All right, I think we have that pretty well down, but I want to do one that's a little bit more complicated. So how many seconds are in a minute?
60.
How many minutes are in an hour?
60.
So then how would we go if we needed to go from hours to seconds? What would we do you think? How many seconds are in 1 hour? That's what we're trying to figure out. Any idea how to figure that out? So 60 seconds in 1 minute times 60 minutes in 1 hour would mean we have 3,600. So you just multiply these two together. 6 times 6 is 36, and you add your zeros from here and here. 3,600 seconds in 1 hour. So our conversion factor for that, from going to seconds to hours, what would that look like?
You just put one over the other?
Right, exactly. So you would put 1 hour over 3,600 seconds, or 3,600 seconds over 1 hour. Okay? So that gives you the conversion factor, and I'll show you how to use the conversion factor here in just a second. So then we're going to learn about how to convert between measurements using the factor label method, and then I'll tell you about it and then we'll practice it. So first, you put the measurement that you're given over 1, because anything divided by 1 is itself, right? But that lets us put it in a fraction so you know where the top and where the bottom are. So you put it over 1, the one that you're given in the problem. Then you write a conversion factor. And we just learned how to make conversion factors, but the way that you know which one of those two, because we saw each time there were two options, the way you know how to choose which one of those two conversion factors to use is you want to put the unit from the one that you're given on the bottom. So when the units match, you want them to go one on the top of your one that's over 1. You want the other one to go in the denominator of your conversion factor. So that will tell you what to put in the top, right? In the numerator position. And then you multiply the given measurement fraction by the conversion factor, and now you have your converted measurement. So we're going to practice using the factor label method. If I wanted to say how many inches are in, how many feet are in 45 inches? Walk me through, first of all, how to create my conversion factor. We did it just a second ago, this exact one. And then which one to put on top and bottom. So 1 foot equals 12 inches. Then what's the conversion factor that we're going to need? So our given one, we put over 1. Then we're going to multiply, and we're going to have a numerator and denominator over there. And we want our given measurement to be in the denominator. So which one of those am I going to put in the denominator?
45 inches.
So we have our 45 inches already here. We're trying to create a conversion factor. So it's going to be 1 foot to 12 inches, but you're right. We want to put the inches on the bottom so that we have inches here and inches over here. So we're going to put our 12 inches here. And then we learned that what goes on the other part is the other part of the conversion factor, so 1 foot. The way that you can remember which way it needs to go is because in algebra, if you have something on the top in a multiplication problem and something on the bottom, you can cross it out, right? So I can cross out inches and I can cross out foot or inches over here, and I'll end up with feet in my answer. And that's what we want, right? We're trying to figure out how many feet there are in 45 inches. If I go ahead and multiply, I will have 45 feet, I guess is how I should write that, not foot. 45 feet, because I have 45 from here, and I have 1 foot times 45 is 45 feet. And then here I'm going to multiply 1 times 12, and I get 12. Now I crossed out my inches so I don't have any kind of label on the bottom. So when I actually do that division problem, I'm just going to divide 45 divided by 12. Can one of you do that on your calculator and tell me what that is? Do you have a calculator with you? I should have told you that you need one of those.
3.75.
Right. So 3.75 feet. So we know now that 45 inches is the same as 3.75 feet. Right. For the next one, I want to convert between liters and milliliters. So if I have 2.5 liters and I want to find out how many milliliters that is, tell me how to do that. Walk me through it.
2.5 over 1.
Yep. So we put what we're given over 1, then we multiply. And what's our conversion factor?
Somewhere in there, there's 1,000 milliliters.
That's right. Your 1,000 milliliters goes on the top because we want to end up with milliliters. So that's going to go on top. And then what goes on the bottom?
1 liter.
Right. 1 liter. So then I can cross these out and I multiply. I'm sure that you already know this, but just in case you don't, when you multiply by anything that's a multiple of 10, you just move the decimal point over as many times as there are zeros. So I'm going to move the decimal point over 3 times. 1, 2, 3. I fill in these spots with my zeros. So 2,500. 2,500 milliliters over 1. So So that's just 2,500 milliliters. Let's do one with time. If I wanted to say, I want to change 2 hours to minutes, what would I do?
You put 2 hours over 1.
Yep.
And then put 60 minutes.
Yep. Because you want the opposite, right? We have hours up here, so you want the opposite so that the hours can go on the bottom. So 60 minutes.
And then 1 hour on the bottom.
Right. And then we multiply. We cross out our hours and we multiply across, so we get 120 minutes. And I'm not going to write the over 1 because we know that over 1 just means that it's itself, right? So 120 minutes. Now, I want to take that same one and say instead that I did want seconds. And I'm not going to remember necessarily that 3,600 seconds are in an hour. So if I wanted to convert from one to the other, but I wanted to do it in steps. So let's say I wanted to find out how many inches are in 4 miles. I'm not going to go, oh, I know how many inches are in a mile. I would go from inches to feet and from feet to miles, right? So we're going to do the same thing here. So 2 hours over 1 times our 60 minutes over 1 hour. And then I can do my next conversion factor just in a row. So now I've crossed out hours, but I want to cross out, oh, that was a strange writing of that. That didn't make any sense. 1 hour. Then I cross out my hours and I put my next conversion factor from minutes to seconds. So I want minutes to cross out. So I say 1 minute so that those can cross out, and 60 seconds. So now my final label is going to be seconds, which is what I'm going for. And now I just multiply across. 2 times 60 times 60. Can somebody tell me what that is?
7,200.
7,200 seconds. So that's how conversion works. That's how you go from one unit to a different unit. Now, we've done all of them within the same measurement system. So we did inches to feet. We did within time, that has the same one. So I want to do one more that's changing between systems. So you may or may not know that 1 inch equals 2.54 centimeters. So if I know that I have 36 inches and I want to figure out how many centimeters that is, tell me how I would do that. Any idea? I'll start and jump in if you know. So you put the 36 inches on the top and put that over 1, and you just do the conversion factor just like we've done before. Times, we want to put our inches on the bottom so we can cross them out. 1 inch and 2.54 centimeters. So now my inches can cross out, and I multiply across. 36 times 2.54, and what are you going to end up with?
91.44.
So 91.44 centimeters. Okay, so like I said, you can convert within the same one. You can convert across different measurement systems as long as you know how they relate to each other, right? Next is adding and subtracting units. When you add and subtract units, you have to remember that you can only do it if the units are exactly the same. You know how to do this, I'm sure, but I just want to make sure that we are catching that you can't combine units. So if I were going to add 5.2 meters plus 3.8 meters, can I do that? Yes, I can, because meters and meters are exactly the same. So I would end up with 9.0 meters. So I'm allowed to do that. What about 2 liters plus 500 milliliters? Can I do that? Maybe. Okay. The way it is, I can't because they're not the same. So milliliters and liters are not the same thing. So I have to convert from one to the other. So I would change my milliliters to liters or vice versa. Either way works. So I'm going to change my 500 milliliters by doing what we've been doing all along. Oh, sorry, that was supposed to be 1 liter. I cross out my milliliters. I have 500 liters divided by 1,000. We do the same thing as we did before when we multiplied by a multiple of 10, but now we're dividing, so we're going to go backwards. So I'm going to start with my decimal point where it would be and go back 3 because I have 3 zeros. So 1, 2, 3. So my answer is 0.500 liters. So now I have 2 liters plus 0.5 liters. So I have 2.5 liters. So now I can add because now they're exactly the same. The same thing is true if I have 3 cubic centimeters plus 1 centimeter. I can't add those because they're not the same. The exponent means that it's different. So remember that you can't add those two different things. They're different. One is measuring volume and one is measuring distance. So I can't do that. It's different if you're multiplying and dividing though. When you're multiplying units, you can combine units any way you want to pretty much as long as they're in the same measuring system. So you don't want to combine grams and inches, but you can combine pretty much anything else as long as they're in the same system. So you can actually end up with something called a foot-pound. So that measures torque. You can divide and end up with miles per hour. You just end up with a label that's something divided by something else. And that can happen. So we're going to practice that for just a second. If you have, let's say, 60 miles, and I'm going 60 miles in 1 hour, I'm not going to go into how you can use this at the moment, but you can actually end up with 60 miles per hour. That's a unit you're used to, right? Or you can do, if you were trying to figure out, you knew that something was exerting a force across, or this is torque, so it's turning, but 5 meters or 5 feet of turning, and it's doing it with 3 pounds of force, you would actually end up with 15 foot-pounds. That's an actual measurement. So if you're multiplying and dividing, you can just keep whatever weird units you end up with, but in adding and subtracting, they have to be the same, okay? Like I said, you can't add and subtract with cubic units or squared units with ones that are not the same. So I can't add something that's a cubic centimeter to something that's a square centimeter or just a plain centimeter. So you actually have to convert those as well. So to do conversions of squared or cubed units, you simply use the conversion factor as many times as you need to cancel out the exponent. So we're going to practice that. So if I have 5 square meters and I want to figure out how many square centimeters that is, my conversion factor between meters and centimeters is 1 meter equals 100 centimeters, right? So if you have done algebra, you know that this means 5 meters times meters, because anything squared is something times itself, right? So you can actually write it out that way. And I'm going to put that over 1 times, and then I'm going to use my conversion factor. And which one should go on the bottom? Meters or centimeters?
The meters.
Meters. So my 1 meter will go on the bottom, and my 100 centimeters will go on the top. Now I can cross out one of these meters, right? I can't cross out both because I don't have 2 on the bottom to cross out, but I can just do it again. So now I do the same one again, 100 centimeters over 1 meter. And now I can cross out my other meter. And now I have centimeters times centimeters, which is what I want, right? So 5 times 100 is 5,000, times 100 is 50,000, or sorry, 500 times 100 is 50,000. So I have 50,000 centimeters squared because I multiplied my two labels on the top together. Let's do one more example from that one. If I have 0.5 cubic liters and I want to figure out how many cubic milliliters, that's what I'm ending up with, right? Because I'm going to go from volume to volume, and volume is measured in cubic things, right? Because when you've done volume of things before, you know that it's width times length times height, so you end up with a cubic something as your answer. So we need to say from volume to volume. So we're going to end up with cubic milliliters, and I'm going to do my conversion factor 3 times instead. So 1,000 milliliters. So that crosses that out, takes it down to squared. You also, if you don't want to write that out, L times L times L, you can just change the exponent. Then I'm going to do it again. So that takes out another one, so then I'm just left with L. So if I do it one more time, I cross out the last one, and now I have milliliters times milliliters times milliliters, so my answer is in milliliters cubed. And then I do 0.5 times 1,000 times 1,000 times 1,000, so I'll go 0.5 and move it over 3 times, and then 3 more times, and then 3 more times. Now I'll fill those in with zeros. So 1, 2, 3, 1, 2, 3. So it's 500,000, or sorry, 500 million milliliters cubed. So that's how it works doing that. The next thing you'll need to know, I want you to write down these 3 equations to help you learn how to convert from Fahrenheit to Celsius, from Celsius to Fahrenheit, and from Celsius to Kelvin. So these are 3 different measurements that we have for temperature, right? So Fahrenheit would be the English system, Celsius is the metric system, and then you have Kelvin, who invented his own because he said that he would like to know what if you got atoms to not move as close to not moving as possible, that he wanted that to be 0. So 0 Kelvin is called absolute 0. That's when molecules don't move at all. And it is really, really low temperature. So you have to take Celsius and add 273.5 to get to where it is. So then we're going to practice converting among the temperature scales. I'll write it down here just so that we'll have it. Degrees Celsius is Fahrenheit minus 32 times 5/9. Degrees Fahrenheit equals degrees Celsius times 5/9, or sorry, 9/5. Plus 32 for Kelvin equals degrees Celsius plus 273.15. So if I start off with 68 degrees Fahrenheit, how am I going to figure out how many degrees Celsius that is? Which one am I going to use?
I think you're gonna use the first one.
Right. We're going to use this top one because we're trying to come up with what degrees Celsius is, and we already know the degrees Fahrenheit. So we would say degrees Celsius equals 68 minus 32 times 5/9. So Somebody do that math on your calculator for me. So an easy way to do it would be to put in 68 minus 32, then multiply that by 5, and then divide the answer by 9. So I would do 68 minus 32 times 5 divided by 9 gives me 20. Or if you wanted to do it with the parentheses, you would need to do 68 minus 32 times 5 divided by 9. And you get 20. So our answer on here would be 20 degrees. So 68 degrees Fahrenheit is the same as 20 degrees Celsius. We'll just do one more. If you look at these three, we don't have one that lets you start off with Fahrenheit and end up with Kelvin. If you need to do that, you actually have to do 2 steps. So let's say we have 98.6 degrees Fahrenheit. Do you recognize that specific temperature? That's body temperature in Fahrenheit, okay? So if we wanted to change that to Celsius, we would do exactly what we just did. Celsius equals 98.6 minus 32 times 5/9. See if you can figure that out on your calculator now that I showed you step by step how to do it.
I hope I did this right. It's 37?
Right. 37 degrees Celsius. And then I have to do the second step, whereas to plug this in to this equation now to get Kelvin. So Kelvin equals degrees Celsius plus 273.15. So do that for me real fast.
Was that a 7?
Yes. Sorry, I crossed my 7s.
Did I do this right? 300. I hope I did this right. 310.15.
Right. 310.15. So 98.6 degrees Fahrenheit, or body temperature, is the same as 310.15 Kelvin. Okay, well that's all for today. Tomorrow we'll be talking about significant figures and scientific notation. So that's what's coming up tomorrow, and then we'll be out of the lots and lots of math part and on to other more chemistry-y things. But you're going to need this for chemistry, so we're going to make sure that we've got these fundamentals down. So that's all for today, and I'll see you next time.